We are back at part 2 of this video series on how to answer open-ended questions in science. And today we'll be using the Primary 4 practice paper to do this. Hi, I'm Mr. Long and I'm a science teacher today. So the question we're looking at will be questions 35 and 39 from the Primary 4 Essay 2 2018 practice paper. Now for the other level students, P3 and P5, looking at this video, please take note that question 35 is suitable for P3, 4 and 5 to try, and for question 39 is suitable for primary 4 and 5 because magnets have not been taught at primary 3 yet. So primary 3s, this question will not be so useful for you, so you can look at this question only next year. You do not have to look at it now. Alright, let's get started. Question 35. Now, CT plants 3 similar young plants in 3 pots, P, Q, and R, filled with the same amount of garden soil. The plants are watered with equal amounts of tap water daily. She provides different amounts of the similar nutrients to each plant, to each pot. After 4 weeks, she measures the increase in the height of the young plants and records them in the following table. So you will see a table with 3 pots here, P, Q, and R. And you notice that under this heading, the amount of nutrients given daily changes. Alright. You also notice in this heading, the increase in the height of the young plant also changes. Now, before we look into the question, we should always ask ourselves this. Now, what is the examiner testing me in this question? Or what is the science concept or concepts that is being tested in this question? So how do we know? Well, we need to look at the various questions inside. The clues in all these things will tell us. For example, from part A, you see the word relationship. Alright. From part B here, you see things like variable to be kept the same. You will notice things like one other variable. Now in part C, you will also talk about things like which setup should she use. So in other words, all these hints point to us to this conclusion that this question is testing us about the idea of fair test, and it's testing if the students are able to read a table and interpret the table, and is able to interpret the relationship between the changed variable and the variable that is being measured. What is the meaning of changed variable and the variable being measured? I talked about what is a changed variable in the previous video in part 1. If you missed that, please go to the description below, look for the link back to the part 1 of the video. So today we will focus a bit more on what is the measured variable. So what's the measured variable here? The measured variable here is the increase in height of the young plant. This is what is being measured, we were told, because you see, she measures the increase in the height of the young plants. So that is what we call the measured variable, the increase in the height of the young plants. And all these things will tell us that the concept being tested here, alright, is about what affects plant growth. So this question is about 2 things. The first part is the science concept of what are the variables that affect plants' growth. And it's also testing us about experimental ideas. How do we design an experimental idea? What are the variables we must consider to come up with an experiment that is a fair test? And how can we read a table such as the one above? Do we know that these are headings and what they mean? Can we see what are the changes? What are the trends here? So the concept here will be the idea that plants are living things. Living things need air, need food, and water. And remember, plants get their food by the amount of sunlight they get. And the amount of sunlight can affect the amount of food made by the plant. So these are the few things we must bear in mind before we can start answering the question. So as I said, we'll talk about the change variable. What is this variable change known as? Alright, and what are the variables that is change variable, and the variable that is being measured. So here let's take a look. So the variable changed is the one here, the amount of nutrients given daily. We know that she changed this because she said here she provides different amounts of similar nutrients to each pot. And we also know this is the what we call the measured variable, because it's what she measures, the increase in the height of the young plant. So now that we know this, it's easy to answer part A. From City's experiment, what is the relationship between the amount of nutrients given daily and the increase in the height of the young plant? So you see all the words here, excuse me, amount of nutrients given daily and increase in the height of the young plants are referring to actually how the change variable affect the measured variable. How the change variable affect the measured variable. Therefore, in your answer, all these words have to be in. If you miss out any of these words, it may mean that you do not really understand what is a change variable or what is a measured variable. So the answer to this would be as the amount of nutrient given daily, and that is the change variable. Right, the change variable. The height of the young plant increases. And how do we see? Notice here, from 10 to 15 to 25, as this one increases, look at the height here, it also increases. When you give it the plant 10 ml of the nutrients, it grows to 12 centimeter in height. Give another plant 15 ml of nutrients, it grows to 19 centimeter in height. And the last one, you give plant in pot R 25 ml of nutrients, it grows to 28 centimeter. Therefore, this can tell us that as the amount of nutrients given daily increases, the height of the young plant also increases. The primary 4 is doing the correction. You may pause the video here and write down your answer. And for the rest of you, you can proceed on to look at part B. Now state one other variable that should be kept the same for the young plants used in the experiment. Now the words here are interesting. State one other variable. Now my primary 4s would know, because I've taught this before, that it means that you do not use the variables that have been mentioned already in the question. Alright? So this variable here, this one other variable must be kept the same for the young plant. So back to this, if this is the only variable that we can change, therefore every other variable has to be kept constant. So let's take a look. What are the variables that have been mentioned in the question and we should keep the same or change? So what we should change would be the amount of nutrients given daily. This should change because we've already been told here, right? She provides different amounts of the similar nutrients. So this must change. Type of plants, can we use this as our answer? Let's take a look. But we were already told she used 3 similar young plants. So this is kept the same. We know this has been kept the same. How about the amount of soil? We can't use it as answer because it already says the amount of soil is kept the same. So this kept the same. How about changing the amount of water? Oh, we can't use this also because the amount of water is also kept the same. Now you will notice here, I wrote down these few things. This is also linked to the science concept that's being tested, that living things are affected by air, food and water, their growth and their survival. So the amount of the water here is kept the same. Alright. The air here in this case, I will assume is the same. Alright, whether you are breathing air in a classroom or in a garden or in a field, it's still air. So I assume that to be the same here. If this is the same, the only change part will be this. This part has to be kept the same as well. If I want the only change variable to be the amount of nutrients given daily, then the amount of food the plants make should be the same. How do I make sure this is the same? It can be the same if I give it the same amount of light, because that will affect the amount of food given. So the amount of light must be kept the same. How about the number of plants? You already told that there are 3 young plants. That is kept the same. So now we can take a look at the question again. State one variable that should be kept the same for the young plant. This is one other variable. This was mentioned in the question. This was mentioned in the question. This was mentioned in the question. This was also mentioned in the question. So in other words, I cannot use any of these four as my answer because the question asks for one other variable. Alright, so I can only use this answer, which is the amount of light. So here will be the amount of light. So, but of course many of you use other answers. Let's take a look at the other answers that you consider that we can probably look at. So what if you write down have the plants grow in the same conditions? So you place them in the same place. I grow them in the same place. Is that answer acceptable? I know that there'll be some teachers who will accept the answer because they will explain to you that at different places the amount of light will be different and therefore the amount of food will be different, so we keep them in the same place. Now that sounds reasonable. However, Mr. Long is not accepting that answer. Why? Because I'd like you to be specific into which variable are you trying to control in that same place. Because if you look at other topics like on water cycle, P5, take note, same place can also mean you are trying to control for the amount of water vapor in the air. You're trying to control for the amount of wind. You're trying to control for the amount of heat present. So if your answer is the same location, I, as your teacher, will not be able to know exactly which condition you're trying to control in this place. So being specific means you tell me by having them in the same place, you're trying to control the amount of light. Okay, so therefore, I do not accept this answer. How about things like type of plants, amount of soil, amount of water, number of plants, number of seeds, amount of nutrients given daily? As mentioned, all these have been given in the question already. So I cannot use any of these because the question says state one other variable. It must be a variable that is not mentioned in the question. Alright, now let's go on to the second part. CT, the third part. CT carry out another experiment. She prepared 4 setups as shown in the table below. Alright, A, B, C, D, and then hibiscus plant. Now here we have plants are different. Okay, some are different, some are the same. These two are the same. These two are the same. And here, other conditions like air, water, sunlight. A tick here what I will assume to mean that that variable, that condition is present. Now, CT wants to conduct an experiment to find out how the presence of light affect the growth of plants. This part to find out will tell you this means the, you're right, it means the aim. It shows you how the presence of light affect the growth of plants. So here, the presence of light will be the change variable, and then growth of plants here will be the measured variable. Alright, so as I explained here, the aim is how the presence of light affect the growth of plants. What is changed will be the amount of light, and what is measured would be the growth of the plant in centimeters, I'll presume, because the earlier part was also in centimeters. Now let's take a look at this. So therefore, everything else must be kept the same. What must be kept the same? Then we must know that the type of plants should be the same because different plants grow at different rates. So I can only compare either A and C with hibiscus plant or B and D with sunflower plants. If I compare sunflower plants, let's see what is the change variable. Alright, amount of sunlight is changed, good. But the problem is the amount of water is also different. The amount of air is also different. So there are 3 change variables here. So if the plants grow to different heights, I will not know what is exactly the variable that is causing the change. So I cannot be choosing B and D. What I can choose will be A and C. Same type of plant. Amount of sunlight is different, good. Amount of water is the same, good. Amount of air is the same, good. So that fulfills a condition whereby the only change variable is the amount of light, and all the other variables, type of plant, the amount of water, the amount of air, are all kept the same. So the answer to part C is this. Alright, A and C. And the explanation, because remember, you get no marks for choosing that. You must explain it. And that explanation is what gives you the marks, because explanation tells us to understand the concept here. The only change variable is in A and C is the amount of sunlight. That means that the rest of the variables like air and water are kept the same. Or I can say the amount of air and water are kept the same. Those doing corrections, you may pause here. The rest, you may proceed on to the next question. Question 39. A length of wire is coiled around two rods A and B. The ends of the wires are connected by a battery. So very clearly, for those who have learned this, the P4s and P5, this is what we call an electromagnet. Okay, so whenever you see two things that are present, I will make to count and make sure they are the same. Let's see here. Number of coils: 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of coils are the same. Alright, they're placed at the same height from the plastic container of steel paper clips. So these are the same variables. So what is the difference here? The difference I can observe here will be the type of the rods seem to be different. Okay, so here I will then say that the change variable here will be the type of material for the rod. Different rods, different material. And what is being measured here? Based on the table, I can see what is being measured is the number of steel paper clips which the rod can attract. That is the measured variable. But then let's go in one step, one layer more. What does this change variable tell us? It's actually telling us that measured variable and the change variable tell us that the scientific concept tested here are magnetic material can be turned into an electromagnet, and non-magnetic material cannot become an electromagnet. That is the concept in this question, and if you get that, then the answer will be very simple to you. What is the aim of the experiment? So imagine if somebody wants to ask you a question. Hey, I give you two rods. Can you tell me which is a magnetic material and which is a non-magnetic material? And then, being the scientist that you are, you will design this experiment to find out this. The answer for this will be to find out which of the rod is made of a magnetic material. Now, what is not acceptable will be these answers. To see which rod can attract more paper clips, to see which rod makes a better electromagnet, because such answers do not show me they understand that these are the concepts being tested in this question. It tells me that you do not really know why you're doing this experiment. So therefore, you do not really know the aim or the purpose of the experiment. Because if you know the purpose, then you will know that a non-magnetic material will not attract any paper clips at all. So why do it? So therefore, the purpose must be to identify which material is a magnetic material. Now, name the material that rods A and B are made of. Now that we know that this is the concept, alright, it's very simple. Say name the material. Now here you got to be careful. Did we ask you for the type of material, or they ask you to name or state? If we ask you for type of material, then for A and B, you can say things like, oh, A is made of a magnetic material and B is made of a non-magnetic material. However, the question is name the material. So it asks to identify. There are many words that we can use for this. Sometimes we use state, sometimes you use identify, when you use give an example. So when these are the words given, it tells you that, okay, we want you to tell me what can A be. So you can either tell me A is made of iron, or you can tell me it's made of steel, because these are the two materials that you have learned in your primary school syllabus that are magnetic. B can be anything else. It can be, for example, made of plastic, because the question didn't say these are two metal rods, right? It can be made of wood, it can be made of ceramics, it can be made of copper. Now there are also metals that are non-magnetic. It can be made of a lot of things, so long as whatever you write here are non-magnetic materials, that's fine. Just need one idea will do. One answer here, one answer here. Last question here. When more coils are used for each of the rods, what will be observed about the number of paper clips on the two rods? This question again is testing this concept. So if you know that B is a non-magnetic material, then you will know that a non-magnetic material cannot become an electromagnet. Therefore, it will still attract 0 paper clips. 0 paper clips are attracted. And A, since A we know is a magnetic material, therefore you can say that the number of paper clips attracted increased. Now, what about answers that you have given that Ms. Long didn't accept? Now, some of you, for part B here, right, you wrote things like nothing happens, or you can say remain unchanged. Now, these answers are not as good as this answer, because this is very clear. It asks you for a number of paper clips, so I'm giving a number 0 paper clips are attracted. Alright, or I can say the number will increase or decrease. Nothing happened is not a number. Now, remain unchanged, alright, it's a little bit better than nothing happens, but because I'm now teaching you and developing your ability to give very clear answers, I do not want to accept this substandard answer. Okay, so even if your tutor say this is okay, I will tell you this is not as good as this answer. Given a choice, wouldn't you want to give an accurate, a specific answer, rather than one that is not as accurate and not as specific? Now, before we end this, let me just go back to the table. Alright, now you notice that actually in this case here, this person did the experiment 3 times. What do you think is the purpose of repeating the experiment 3 times? What do you think is the purpose of repeating an experiment 3 times or more? Can't you just do it once and see? If you do it once, alright, you already see this, that, oh, something is, this rod A can attract 7 paper clips and rod B attracted 0. Can we do it just once? Why must we do it a second time and a third time? Now, I'd like you to try and write down your answer in the comments below, and then I will give an answer in the comments after a week. Okay? All the best. I'll see you in the next video.